Well, I'm gonna get started here. I have done all the. I've started with all the basic prep work, for this homework assignment. Oh, before I even talk about the solution to this homework assignment, for the past 2 or 3 homework assignments, I have found, let's just say, suspiciously identical solutions from multiple submissions. So I just want to re-emphasize it is important to do your own homework assignment. I don't really oppose to studying together or talking about concepts together, but sharing the code that people will be turning in is not a very good idea, okay? Because as the programs get more and more complicated, the likelihood of having identical code or near identical code, I can tell what is being done to make programs look different. Okay, so they are kind of obvious to me. The likelihood of having the same program using the same control structure and so on and so forth is going to be pretty slim. Okay, so I'll be starting to take note of those things and let people know. But I do have noticed in the past 2 or 3 homework assignments, there are solutions that are exactly the same from multiple people. And I understand with simpler programs it is possible, but as we move forward to more complex programs, that likelihood is going to be pretty slim. Okay? So I just want to let you guys know that I have been noticing this already, and please make sure that you do not share a solution. You can talk about concepts all day long. I mean, I do not discourage people helping out each other or talking about concepts so that you have a better understanding of the stuff that we talked about in class. But don't talk about it using the homework assignments. Use other ways to talk about the concepts. Okay. All right. So that said, we're going to work on this program. So what we'll do is I'm going to read my own instruction. Okay, I have already done this part here, having a subdirectory called readnum, and also naming my program main.cpp, case sensitive, and everything. So now we want to look at readnum, and the description of readnum is to, as long as end of file of the standard input file is not reached, attempt to read a base 10 number from standard input file. If an error occurs, readnum disposes of the characters one at a time that cannot start with an integer until one of the following 2 conditions is met. End of file is reached, then there's nothing else to read in the file, so it's time to return anyway. An integer is actually read, then you have to return the read integer value as the return value of the subroutine itself. Okay, so this is the general description of what the subroutine is supposed to do, and we'll go ahead and do it here. So before we do anything else, you have to kind of think about the process. You have to start with attempting to read a base 10 integer. If it is not read, then you have to do something else. You have to basically look at how I was not able to read an integer. If it is end of file, then there's nothing I can do about it. It's time to return gibberish. Okay. If I cannot get an integer because it's not in the file, but for some other reason, it means the first character that I'm seeing right now cannot start a base 10 integer, which means, hey, I may be able to just clear away that one character and then try again. But trying again means it's a loop. Okay? So that means you can do it with a loop, and there is a whole variety of ways of putting this program together. I'll go ahead and do it the most spelled out way, okay, not using any tricks, okay, and then we'll go ahead and look at alternative solutions that is shorter and representative of what people would actually do within C and C++. Okay, so now that we know it's a loop, okay, we can start with. I'm just going to use the word loop here, which does not exist in C++. Because I just want to emphasize that we have some kind of a loop, and we want to specify, what we are going to do when we're going to exit. Okay. All right. So when do we exit from this loop? Well, the description of the homework said 2 things. Okay. When EOF is reached, or an integer is read. Okay. I know this is not C, but it captures the logic of this program. Is that working out so far? So you have to keep doing something until either end of file is reached or an integer is read. Okay. All right, so if it is not in a file and an integer is not read, well, what do I have to do here? Okay, that's the question. The first thing you might want to do is to, in the loop itself, because you have to remember we have two types of loops. We have a pre-checking loop, which means we check the condition first, and then we have a post-checking loop, which means we check the condition later on, right? So with a post-checking loop, I can do something first, and then depending on the result of doing that thing, I can choose whether to end the execution or not. So that's what I'll do here. So what I'll do is I will attempt to read a base 10 integer. Now that can give me 3 possible outcomes, okay? So I would say 3 possible outcomes. Okay, 3 branches. The first one is the most optimistic one, okay? If a base 10 number is read, then I will do something. Then I will say, else if EOF, I'll do something else. And then over here is the only one where a base 10 number is not read, and yet it is not in a file yet, okay? This is the only one thing that I can do something about, because I can see that there's something on the conveyor belt, but it's not something that can start a base 10 number. What do I do with it? Come on, you guys know it.
You want to get rid of it?
Yep, just get rid of it, right? Okay, so to get rid of something, you know, there's the chunk of code is already described in the homework description itself. So we just declare a local variable ch and say scanf %c, which means I want to just read a single character and get rid of it. Okay, that's it. What about EOF? Is there anything I can do about EOF? I was asked to read something, to remove something on the conveyor belt, and yet the conveyor belt has stopped already. There's nothing on it, and it's stopped.
You want to return it?
You can return anything you want. I mean, it doesn't really matter. Okay, so this means, you know, do nothing, but we do want to get out of the loop. Okay. And this one also has nothing to do because, you know, just return it, right? Just return what was read. Okay, so at this point I have captured pretty much, you know, the logic of the code, but not so much expressing the code in C or C++. Okay, so we'll go ahead and start to convert these things one at a time. We'll start with attempting to read a base 10 number. So I will turn this into a line of comment just to remind myself what I'm supposed to do here. Now we know that this will do it. And I also need a local variable, so we'll just use x here. So I'm going to read it into x. Okay. All right. So line 9 is good so far, you know, because it is going to read an integer from standard in, or try to do it and put it into x. But it's not going to help me with line 10 or line 14 because, you know, just looking at scanf like it is now, by the time I get to line 10 or line 14, I would not know whether a base 10 number was actually read or whether it's end of file or not. So what do you think I need to do on line 9? There's something I need to do on line 9 in addition to just doing scanf. What do I need to do? The return value of scanf is useful, so I better save it first, okay? So I'm gonna put it into something else. We'll put it into y here, variable y. Okay. So now I have a way to proceed onto line 11, okay? Line 11 is supposed to find out whether we have read a base 10 number, okay? So I'm gonna turn this into comment, and then we can put it here. How can we confirm we just read a base 10 number?
Y is greater than 1, or
Y
1.
is exactly 1, right? Because we asked scanf to read one thing. If it is returning 1, it means it read the one thing that I asked it to, which is a base 10 signed number. So if y equals to 1, that's actually nothing to do. Fine, that's okay. It's perfectly okay to leave a block statement empty like it is here. Okay, that's perfectly okay. Let's look at this case here, okay? How do I know it is end of file? And there's nothing I can do about it.
Y equals negative.
y equals to -1, okay, or less than 0. Okay, so when y is less than 0, or you can just compare to -1, it confirms that we are at end of file, and there's absolutely nothing I can do about it. Very good. Okay. So now the body of the loop is all set up. We go back to the actual loop here, and we say end of file is reached when integer is read. Okay. When you look at the conditions on line 11 and also on line 15, that's already telling you how to detect these two conditions. Okay. So we'll go ahead and convert things one at a time. We convert the OR into bars. Okay. But remember, this is the exit condition. This is not the stay in loop condition. But that's okay, we can fix that later. EOF is reached. It's the same thing as the condition on line 15, right? Yeah. So we'll say y is less than 0. And integer is actually read is the same condition as on line 11, which means y equals to 1. Okay. And since this is going to be a post-checking loop, now how do I know this is going to be a post-checking loop?
You want it to execute at least once.
Yep, because we have to scan f first in order to find out what y is. Now you can go ahead and assign y with like a -1 with a value of 0, so that it would go into the loop the first time. But that's kind of artificial. I prefer to turn it into a post-checking loop, which means it's going to be a do-while type of format. Okay. But the while format is the reverse of a repeat until. In other words, instead of stating the exit condition, I have to state the stay in loop condition. The easiest way to turn an exit condition into a stay in loop condition is just to negate it. Okay, which is not particularly elegant, but it's one way to do it. So if I just want the program to work, this will work. Okay, it's not pretty. It is a whole lot longer than it has to be, but it does go through, every single step that I have to go through to think about the problem, and it also spells out, how I, look at each individual case. Okay, I attempt to read something. There are 3 possible outcomes. I evaluated each and every single one. For certain things, there's nothing to do. For certain things, I have something else to do. But it does capture all that logic. Okay. So if my objective is really just to get the program to work and turn it in, this may work. Okay, so I'll give it a try. So we'll go ahead and give it a try, and I'll give it the test cases that we were talking about, the 7 test cases. So you go back to the beginning of this class, or just go to the news forum, and then download that file, unzip it, and that will give you all the test cases. So it is this one here. Right click, save link as, and I can put it into my temp folder. Go back to my command prompt, tar xzbf tests. There we go. All right, so now we have all the test cases, but before we go there, we have to compile the program first. So warn all -g-c, and this is main.cpp. Oh, we have an error, so we will fix it on line 26. Oh, okay, forgot a semicolon there. Compile again, no error this time, just a warning of a problem in main. Nope, this one is in read none. No return statement. Ah, okay. So I have missed the most important part of this whole thing, because I'm done with everything, but what did I do with the result? Yeah, we just toss it into the trash can. So we're going to use a return statement to return the one thing that I was asked to do, which is x. Okay, so return x here. There we go. Okay, much better. Okay, compile again. No errors. Good. Link the program, and if I feel brave enough, which I'm feeling right now, okay, this just pops up in my mind, Clint Eastwood, do you feel lucky, punk, with his mouth barely, with his lips barely moving, right, Do you want him as a mayor? Well, probably as Clint Eastwood, but not as Dirty Harry. All right, so we'll go ahead and run the program. Okay, we'll give it test1.in, and we'll capture my own test result as my test1.out. And now we can compare using vim.o. Okay, so I can display my answer on one side and then the correct answer on the other side, and they're both empty files. That's good. That's what it's supposed to do. Okay, and we'll go ahead and test another one. I'm not going to bore you with all 7 test cases. I think the test 6 is. Oops. Okay, I have to run the program first. There we go. How many people actually wrote a script to do this? Was it useful?
Yeah.
Saved a little bit of time? Yep. The best part of writing a script to do it is, yep, so that one's good too. So let's try the last one, which is supposed to have something in it. Okay, fix this part first. The best part of writing a script to do it is you don't have to worry about forgetting to test something, because it's going to do the same 7 tests every single time. Or if you want to add your own, that will work as well. So I know this program does work. Okay. So now that I know the program is working, if that's your objective, we're all done. We don't have to do a single thing about it. But I look at this program and go like, well, that looks kind of long and doesn't need to be that long. Okay. So whenever you see an empty branch in a conditional statement, you kind of have to ask yourself, well, can I make it a little bit shorter? Okay, do I really have to keep all the empty branches? In this case, I don't have to keep the empty branches. So the first empty branch is from line 12 to line 14. It's empty, there's nothing in it. The second one is from line 16 to line 18. Once again, we don't have anything in it. So now the question is, can we condense the entire conditional statement from line 11 all the way up to line 23 into a much shorter one and only catch the time when I have to do something about it? In other words, what is one way of saying y does not equal to 1 and y is also not less than 0? And we can do it but there's one thing. Okay, let me put this up first. Okay, so we'll go ahead and specify when it is not the case that y equals to 1. Actually, okay, when y does not equal to 1 and y is not less than 0. Okay, so that's basically what we mean, and then we can get rid of the other branches. Okay, is that okay so far? Can we simplify line 11 a little bit here?
Y equals 0.
When y equals to 0, because y can only have 3 possible values: 0, -1, or 1. If it is not 1 and it's not less than 0, it has to be 0. So now we can simplify it a little bit. Okay. Now, obviously, when you are doing this, you might want to do it one step at a time, just to make sure the meaning has not changed. Okay. So that would be a good way to do it. But I can shorten this even a little bit more. To compare to confirm that y is 0 is to confirm that y is false, right? Because anything that's 0 is considered false as a condition. So to confirm something is false is kind of saying the same thing as that. Because when y is 0, 0 is false. Not false is true. So when y is actually 0, not y is true, and we'll do what needs to be done when y is actually 0. How many people made the mistake of using a single equal symbol instead of 2 when you compare to 0? It happens all the time, okay? So don't worry about it. It happens to every single person that I know of. Okay? People who say that it has never happened, either have not written enough programs or did not remember that they made that mistake, because it is a very common mistake. Everybody makes it. Okay? All right, so let's see if this is better. Okay, let's see if this program, which is a little bit shorter, is going to work or not. You know what? I can change this one now too, because now that I know that y can either be -1 or 1 or 0, it means if it is not less than 0 or not equal to 1, isn't it the same thing? Not y is going to be good. Okay, so we'll do the same thing here. Because when y equal to 0 is the only time I can do something about it and try again. All right, so let's go ahead and redo the whole thing. So we'll say 554 and 555. And then we'll go ahead and retest the program using number 7, test case number 7, 561, and use 562 to look at the output, and it's still behaving the same way. So that's good. Okay. So now the question is, are we done yet? Can I go get my cookie for lunch? Because we have been talking about cookies for a while. How many people actually went and got some cookies? Nobody. You did?
Yeah,
Okay.
I just went and get the chocolate.
The vending machine?
Yeah.
They should start to pay me for. I need to get a cut of that action. Okay, so now the question is, can I change this program and make it even shorter, but not necessarily easier to read? This is probably the best in terms of readability. Okay, it's easier to read. Everything is spelled out. There are no really neat tricks here. Okay, so what I'm going to do is to turn this program into a shorter program, but not necessarily a program that is easier to understand. Okay, for whatever reason, C and C++ programmers, for whatever reason, write programs that are like that. Okay, so even if you're not going to write programs in this particular way, you probably will encounter programs written this way as a programmer, as a person who is in the programming trade. Okay, so what I'll do is I'm going to turn this into a while loop. You say, well, but that's not going to be easy, because if I do it like this, that means I'm gonna there's a possibility that I do not even enter the loop at all. So what I'll do is I'm gonna do this. Okay, I will put this line here. And get rid of it here. And then we'll put the negation here. That equal symbol here is not a mistake, it is intentional. Because now I have okay, when you look at line 7, let's find out what is the order of doing things here. When I get to line 7, the first thing I do is a scanf. Is that okay? Fine. Yep, go ahead.
So if instead of a single equal, I put double equal over there, so what happened?
Sorry?
If I put double equal,
if you put double equal here,
yeah,
then it will actually compare to y, and since y is not initialized, that means your program is unlikely to work correctly.
okay.
But in this case, since I have a single equal, it means something completely different, okay? Because this is the first thing I will do. Scanf will still do the same thing as scanf should do. It will try to read the base 10 number, return a 1 if it did, return a 0 if it could not because something that is non-digit is there, or it will return a -1 when it's already in a file. It's do the same thing as last time, right? But instead of using that value in any other way, I would store that number into y. That's the job of a single equal symbol. It's an assignment operator. But as an operator, this whole thing as an expression has a value. The expression itself has a value, which is the right-hand side of the assignment, which is the result of scanf, right? So I'm going to use that value, either a 0, a 1, or a -1, and apply the negation operator on it. And the negation operator is going to say, if not that something, right? Not 1 is false, gets me out of the loop. Not -1 is also false, because anything that is non-zero is true, not true is false. So whether scanf returns a 1 or a -1 to me, both will get me out. Is that making any sense? The only time I would go to the body of this loop is when scanf returns a 0. Is that okay? Well, if that is the case, that means by the time I get to line 9, y is guaranteed to be a 0. If y is guaranteed to be a 0, why do I have to check it? I don't need to. And as a result, this block can now be reduced as well. Okay. Like that. Do I even need y anymore? And since this is not a complex operation, I don't need the extra parentheses. So I'm saying that this will do exactly the same thing.
You still have to initialize y.
Say again?
You still have to initialize y.
Y does not even need to exist. Because I'm utilizing the result of scanf right away. So I'm saying, okay, scanf, did you just give me a 0? Because that's the only time that it really matters. If it did return a 0, I'll go ahead and clear one character out of standard in and then try again. If it gives me a 1, I'm going to get out of the loop because I just read an integer. It's time to get out and return that integer. If it gave me a 0, it's also time to get out of the loop because I'm at end of file. There's nothing I can do at this point, so I still need to get out of the loop. So by kind of analyzing the code and just each time I try to optimize it a little bit, I eventually turn the program into this form, which is a lot simpler, but it's also trickier because it does not spell out the special cases that you have to consider when you look at the return value of scanf. Okay, so the bottom line is I do not expect anyone in this class to clean up the code to this particular degree. Okay, so don't worry if you say, oh, but there's no way I can come up with this solution. Don't worry, I'm not expecting that, okay? But if I give you this code, you have to understand it. And if I give you this code and the original code, given some time, you should be able to establish and say, oh, they're really equivalent. They're doing the same thing. You have to be able to understand the code and understand scanf enough to make sure that they are actually functionally the same, even though one is kind of terse and not spell out things like this one. Are there any questions about this? Now, if I really want this to be even shorter and trickier and and all sorts of stuff like that, I can do it, but it's kind of a push here. I can take out line 8 and then say, I don't really need a ch here. I can do a x here. Now, this is going to be a problem because x is an integer, and I'm supposed to get a pointer to a character here. Okay, but if you think about it a little bit, it's actually okay. I can do something about it. Okay, this is something that we talked about a long time ago. It's called typecasting. Okay, you can tell the compiler that you know what you're doing, and then it can change the type of something to something that is different. Okay, so I can now say to the compiler and say, just look at this as a character pointer or a character address. So I'm taking the address of an integer, which is using up 4 bytes, and try to convince the compiler and say, don't look at this as an address of something that has 4 bytes. Just look at this as the address of something that has only 1 byte. The compiler would do it, okay? Because whenever you use typecasting, you are saying that you know what you're doing, and you're convincing the compiler to let you do it. In this case, it will let me do it, and it is okay to do so, because when I'm overwriting 1 byte of something that has 4 bytes, and those 4 bytes is yet to be determined, it is actually not harmful, okay? But this is a very bad hack, okay? Bad way of doing things, because there's a potential that x has a useful value, and now I'm destroying it. So that's why this is one modification that I would not do. I would just keep it the way it is as this form here. Okay. Are there any questions about all this discussion? Now, when you guys were writing this code, what was the most difficult part of writing programs?
For me, the find out where the EOF.
Where to put the EOF?
Yes.
You mean checking for -1?
Yeah.
Okay. So, did you kind of do it the way I did, like, get it first and then analyze what to do with it?
Yeah.
That's one way to do it, because you can store it first, because once you store the return value of scanf, then you can use a long, conditional statement to process it and go like, okay, when it is 0, this is what I need to do. If it is 1, this is what I need to do, and when it's -1, this is what I need to do. Okay. Any other comments about the experience of writing this particular program? No? Was it easy, medium, hard?
This is very challenging.
It was hard, actually.
Okay, it's challenging. Okay. I can see how this program is challenging for people who are majoring in math or science or engineering. Now, if you think about it, why would it be difficult for of STEM? Okay, it's difficult for STEM. Okay, because computer science is not a part of STEM, science, technology, engineering, and math. Okay, but why is it like that? In math, what is sequential? In math, in a math class, what do you have to do that has a sequential nature to it? A mathematical proof, right? To derive something that has a mathematical nature to it, or it has a sequential nature to it. But within that sequential nature, do you have to think about loops, conditional statements, branching, and stuff like that? Nope. Okay. In engineering, what has a sequential nature to it? I mean, you have steps to design something like a gear, okay? So you have a lot of math, a lot of requirements, to consider. But there are very few things that has a sequential nature, and within the sequential nature, you have decision making also. And I think computer science can be a little bit different because of that, because you have to think about, oh, this is step by step. Perform this step. Perform this step. Oh, I might need to go back to an earlier step, okay? But only when a certain condition is true. So I think that's why computer science or programming itself sometimes can be a little bit challenging to people who are otherwise really good at math, science, like physics. Okay, physics actually involves a lot of interesting concepts. Okay, but someone who's really good at physics can look at programming and go like, well, I don't know how to put things together because it requires a slightly different way of thinking. It is step by step. Okay, thinking about what do I need to do next, and do I always have to do that? Okay, is there an alternative that I have to consider? If so, how do I specify the condition to go the other route sometimes? I'm not really quite sure how to teach that part, okay, because that really is the most difficult part to teach. The standard, easy, you can look it up, okay. Specification of the format string, yes, it is tedious, it is a long description, but yet, it is just a description. How to put a program together is the difficult part. Any comments from those of you who spend some time and kind of think that, well, I kind of have an idea of how to make this happen, other than putting everything into a slow cooker and just wait?
Pretty much how you do it, how you just start off pretty general terms and then break it down.
Break it down. I would also take a look at the major ingredients. In other words, in this particular program, we know scanf is going to play a very important role. So we would focus on scanf and look at the conditions related to scanf, what is returning. Once you know it's a loop, then you can already think about what would go into the condition and what would go into the body. Whenever you deal with a loop, you think about the exit condition first, because the exit condition will help you determine what to put in the loop itself. Because what you put in the loop itself usually has something to do with the exit condition. Yep.
I think generally it was pretty easy, but there were a couple things that I was missing that made it really difficult for me. The first one was it was mainly had to do with scanf. First, you put a character in there, and then it just goes away. I didn't know that. I missed that, so I was trying to figure out how to get out, leave the character, and I couldn't do it.
That's a good point. Can you remember what you're about to say?
Yeah.
Okay. So I'm just going to interject here. When you are at a point where you're not quite sure what it is going to do, write a much shorter program just to test it. In other words, in the case of scanf with a %C, write a program with like 4 or 5 sequential scanf with only %C. Just run that program and give it some test program and see what it's doing to the input. That would be one way to write programs. Because unlike in physics or in some other disciplines of STEM, programming you can afford to test it. You're not going to blow anything up. You're not going to destroy anything, okay? Unless it's a system scripting class, then you can do some serious damage. But in this class, it's not the case. So I would encourage people to kind of play with it. Just experiment. If you're not sure what it's going to do, form a theory in your head, test the program. If the program does not do what you think it's supposed to do, then you have to look deeper. Okay, go ahead. Sorry.
Well, besides that, the other big one was just the outputs of the scanner. As long as you know the outputs, then you kind of put the syntax together.
You mean the return value?
Right.
Yep. All right. So there's some reading, some documentation part of it.
Yeah,
Yep.
just understanding scan out, but you emphasize that really well. It helped out.
Okay. And the test files, should help out a little bit too, because that gives you an idea of exactly what should be the output of your program given a particular input. Anyone else want to talk about it, or no?
I figured it out, so I'm feeling pretty good.
The more you do it, the quicker it gets. It's the same thing as riding a bicycle, really. For the most part, the first time you do it, you might be even overthinking it. Like when you're learning how to ride the bicycle, most people overthink it. It's like, oh, I need to balance and whatnot, but they forget that if you just keep rolling, it will maintain the balance. You can maintain balance a whole lot easier. For that matter, I really should learn how to skateboard. Just so that I understand the process of learning something new. But then you might see me, coming in a wheelchair, if I were to do that. So that might not be very productive. But it does get easier because your brain will get accustomed to thinking in a particular way. All right. Any other points? No? Okay, so there's no homework assignments here for today. I will give you guys another one on Wednesday, so you have a little break from homework assignments, which is not to say that there's nothing to do, because what I cover today is actually quite a bit, okay? The combination of taking the address of, dereferencing, and taking a member of a structure, you kind of have to go through all that stuff and make sure that you understand how those concepts can be combined, because each one is independent from the other ones, but yet they can be combined in a way to make certain things work in our last program. All right, so if there are no additional questions, I'm going to stop the recorder. If you guys want to stay in the lab and do whatever, that's fine with me, and I will be able to answer questions as well.